Okay, let's talk a little bit about ANOVA, analysis of variance. What I've got here is an example. I've got first shift, second shift, third shift. Is there a variation between these shifts? Or is there a variation between the machines, 1, 2, or 3? Or is there some kind of interaction here, right? And this is just a factory example. You could use this with medical, doctor, days of the week, or if you're a trucking company, you got truck 1, truck 2, mileage, or a driver with the mileage in here. It's endless how you can use this. So I've got a couple of hypotheses in here. First hypothesis is that machine 1 is equal to machine 2 is equal to machine 3. So I'm saying there's basically no difference between the machines, right? And then of course I got shift 1 is equal to shift 2, and that's equal to shift 3, no difference, right? And then I got that interaction one, and I'm not going to talk about that. We're going to have a chance to talk plenty of times with that when we get into DOE or design of experiments. So there we go. I got my concept. It has to be set up like this: shifts and machines, the two factors. So I'm going to come up here to the top, and I'm going to click on data. And I've already showed you how to do the add-ins to get this data analysis package up here. I'm just going to click on that. And I want an ANOVA two-factor, machine by shift, without replication. I'm just going to click on OK. It's going to ask me, what do I want? I'm just going to, let me do this wrong. I'm just going to highlight that whole thing. It's got labels in it. I can set my alpha rate. So this is for that alpha. This is my type 1 error. I'm going to put up with a 5% chance I'm getting this wrong. Click on output. I'm going to come here and click on where I want that. Just click OK. And this pops up. Okay. And I'm not going to spend much time on this other than to show you, here's the variance, right? This is the important part because we're going to analyze where is our variation coming from. Okay, so it'll figure out the shift, it'll figure out the machine, and then it comes down here and it says, oh, okay, rows. Again, 14 degrees of freedom. Where does that come from? 1, 2. See these little lines between the numbers? There are 14 of them. Boom. And you look at the columns. There's only 2 of them there, right? And the error, that's in other words for where the interaction is. 14 by 2 or 28. Okay. Now what you got here is this one here will crank out the F statistic, right? And then because I set the alpha at 0.05, it'll also calculate the critical value of F. If you want to look in the table, and these will match the table hopefully for 0.5. But what I'm really interested in is this p-value, right? So this p-value, like all p-values, at 0.003109, that tells me that there's a 0.3109, that the variation I'm seeing from row to row to row is a result of random chance. So if p is low, HO must go. So there you go. We just said, nope, that's not going to work. The other one I'll calculate is the columns. Machine 1, machine 2, machine 3. It's saying the variation between these two machines, almost no chance that that's random chance. None. I'm going to say that. You rarely hear me say that. So this null hypothesis gets tossed out. If p is low, HO must go. So I'm saying these differences between the different machines, differences between the shifts, they're real. They're statistically significant. So then I come in, I go start picking this apart, analyzing and doing my improvement techniques. But that's analysis of variance, okay?